So thermal properties of matter, we'll try to do some problems better. See this one. First problem better. Two materials having the coefficients of thermal conductivity 3K and K. Two materials having the coefficients of thermal conductivities 3K and K and thickness D and 3D. Like say here it is given for this is 3K, this is K. Thickness of the first one is D, next one is your 3D. Are joined to form a slab as shown in the figure. The temperature of the outer surface are theta 2 and theta 1. Okay, here it is theta 2 and here it is theta 1. And theta 2 is greater than theta 1. The temperature at the interface is how much? So that means somewhere here, what is the temperature? Can anyone try it, beta? Can anyone try it? Can anyone? Two materials having, see here, if I draw this material like this, this is your material. The first one is having, let me just take the diagram. First one is right now for me 3K, and next one is your K. Thickness of this one is D, and thickness of this one is 3D. Interface temperature is theta, here it is theta 2, and here it is theta 1. Theta 2 is greater than theta 1. So whatever heat is flowing through the first rod beta, the same amount of the heat flow from the second rod, isn't it? So if I'm assuming at the temperature theta at your steady state, option D, very good. So I can say that rate of your incoming flow, rate of heat flow in slab 1 must be equal to the rate of heat flow in slab 2. What is the rate formula? Q by T is equals to Ka into temperature difference divided by length. So first one, thermal conductivity is 3K into area is nothing but A, temperature. This is higher, so it is theta 2 minus theta divided by length of this one is your D is equals to thermal conductivity is K into area A, and theta and your theta 1 part of relation. Theta will be higher temperature because it is flowing from higher temperature to lower temperature. So theta minus theta 1 and divided by your, this distance will be equal to your 3D. Anything is getting cancelled in this one, you see better. This Ka and this Ka will get cancelled. This D and this D will get cancelled. So this will be 3 and 3, this will become for me 9. 9 into theta 2 minus of theta is equals to your theta minus of your theta 1. So this will become for me 9 into theta 2 minus of 9 theta is equals to theta minus of your theta 1. If I am simplifying this one, theta terms you take on other side beta, and theta 1 you take on other side. So this will become for me 9 theta 2 plus this will come here. So this will become for me theta 1 is equals to, this one is your theta, this will come here right now, this one is 9 theta. That means this will become for me 10 theta. So 9 theta 2 plus of your theta 1 is equals to your 10 times of your theta. This one is theta beta, 10 times of theta. So theta will be equal to how much for me? 9 by 10 times of your theta 2 plus of your theta 1 divided by 10 times. That will be the answer. See which option is matching there. Theta 1 by 10 plus of your 9 times of your theta 2. 9 times of your 10 theta 2. 9 times of your 10 theta 2. Theta 1 by 10. So first option will be the answer. Got it, everyone? Got it, everyone? Any doubt in this one to anyone? Clear, beta? No doubt. Okay, chal. Next one. Next question. Two identical beakers A and B contains the equal volumes of two different liquids at 60 degrees centigrade each and left to cool down. Liquid in A has a density of your 8 into 10 to the power of 2 kg per meter cube and specific heat of 2000 joule per kg per Kelvin, while the liquid in the B has a density of 10 to the power of 3 kg per meter cube and specific heat 4000 joule per kg per Kelvin. Which of the following best describes the temperature versus time graph systematically? Yesterday in the last I told you how to draw the graph. And what is the slope represents? Anyone give me the answer? Anyone? Option B. How beta? Nandini? On what basis you are telling it better?
Inversely proportional to
On what
mass and
basis?
specific. Yesterday you told tan theta inversely proportional to mass and specific heat.
See, what is our formula beta for the rate of cooling? dq by your dt is equals to, okay, it is your, in terms of your temperature, if I am taking thermal conductivity K divided by mass into specific heat into temperature T minus of your T naught. Okay, that means rate of your cooling dq by dt is inversely proportional to 1 by your mass into specific heat. That is inversely proportional to mass is equals to volume into density into specific heat. So I can say that dq by your dt is inversely proportional to your density into your specific heat. Okay, so I can say that what is given in the problem beta, density of your A is given. I'm writing the data, you see. Density of your A is 8 into 10 to the power of 2 kg per meter cube. Density of your B is equals to 10 to the power of 3 kg per meter cube. The specific heat of your A, specific heat of your A is given as of your 2000 joule per kg per Kelvin. Specific heat of your B will be equal to your 4000 joule per kg per Kelvin. So I can say that right now, density of your A into specific heat of your A must be equal to how much beta? Density of your A is 8 into 10 to the power of 2, specific heat of A is 2000. 8 just 16, so it is 16 into 10 to the power of your 5. Density of the B into specific heat of your B. Density of the B is 10 to the power of 3. Specific heat of the B is your 4000. So that will be equal to 4 into 10 to the power of 6. Now see on this one, density of your A is lesser than density of the B. Specific heat of your A is lesser than the specific heat of the B. So I can write here, density of your A into specific heat of your A is lesser than your density of your B into specific heat of your B. So I can say right now here 1 by density of your A into specific heat of your A is greater than 1 by density of your B into specific heat of your B. So I can say that rate of cooling of dq by dt of your A will be greater than dq by dt of your B. Is my point clear for everyone? Is my point clear for everyone? So
Yes,
rate
sir.
of cooling is more for what beta? Rate of cooling will be, so for container B, rate of cooling is your smaller and that of your container A, it is more. Hence the graph of your B should lie above the graph of your A. Graph of your B should be lying above the graph of your A. Okay. Graph of your B must be lying above the graph of your A. Is it clear, Nandini?
Yes, sir.
Have you got it? Clear, beta? So which option I can write?
B option.
Barika,
B option, sir.
rate of cooling of your A is greater than rate of cooling of your B. So what I can write here? So I can write that point here so you will get a clarity. Graph of your B lies above A. Okay, so which option? Second option. Okay, so more rate of cooling is for A compared to your B. Okay, sure. Next one. Can anyone try the next one, beta? Very good question. A cylinder of radius R is being surrounded by a cylindrical shell of inner radius capital R and outer radius of your 2R. The thermal conductivity of the material of the inner cylinder is K1 and that of the outer cylinder is K2. Assuming no loss of your heat, the effective thermal conductivity of the system for the heat flowing along the length of the cylinder will be equal to how much? See, we know the formula for this one, beta. K equivalent will be equal to your K1 into your A1 plus K2 into your A2 divided by your A1 plus of your A2. I did this one in the class. K equivalent is equals to your K1 A1 plus of your K2 A2 divided by your A1 plus A2. What we have got, a cylinder of radius R is surrounded by a cylindrical shell of inner radius R. Now see here. So I'm taking here right now one cylinder. Of radius R. It is having one more cylinder here right inside. Like this. Okay. So somewhere here the heat is been flowing in this one. So now heat is coming right now like this. Parallel to this one like this. And whatever heat is being flowing, the same amount of the heat is being flowing out like this. So both the cylinder will be in which combination, beta? They are one above the other. Now read the question carefully. Cylinder of radius R is being surrounded by a cylindrical shell of inner radius R and outer radius of your 2R. Okay, that means outer radius is given as of your 2R. This one is 2R and inner radius about this axis if I'm taking, this one is equals to your R. Outer radius is 2R beta. From here to here, this outer radius, this one is your 2R. Inner radius about this axis is nothing but 2R. They are one above the other beta, so it will form for me what? Parallel combination. So the given cylinders are what in the parallel combination. So I can write here K equivalent. What are the thermal conductivities? The thermal conductivity of the metal of inner shell is K1 and that of the outer one is K2. Okay. Inner one is K1 and outer one is K2. Fine. Assuming there is no loss of heat, the effective thermal conductivity of the system for the heat flowing along the length of the cylinder is how much? A cylinder of radius R is surrounded by a cylindrical shell of inner radius R and outer radius of your 2R. Okay, inner radius is your R. For this one, this will become for me inner radius, and for this one, the outer radius will be equal to your 2R. Okay, so K equivalent is equals to your first one is nothing but K1 into first one area will be equal to pi into your R square plus K2 into area of the next one will be equal to how much beta? Pi into this one is nothing but 2 into your R whole square minus of your pi into your R square. And the E part of area. So I'll just draw it with other pen, we'll get a clarity. So area of this part if I'm right. Okay, total minus this one. So it is divided by total area. Pi into your r square first one plus this one is your this one will be area will be 4 pi into your r square minus of your pi into your r square. Okay, so it is pi into 2 r square na beta. So 2 I have taken the square, that is the reason I got 4 pi r square minus of your pi square part of relation. So if I'm simplifying this one, this will become for me k1 into pi into your r square plus k2 into your, this one is your 4 into pi into your r square minus of your pi into your r square divided by, in this one is a pi into your r square plus 4 pi r square minus r square. This will become for me 3 pi into your r square. So that will be equal to your k1 into pi into your r square plus of your k2 into, this one is also 3 into pi into r square divided by 3 plus 1. This will be equal to 4 pi into your r square. So in this one, pi r square will be common. This will be equal to your k1 plus of your 3 times of your k2 divided by 4 times of pi into your r square. This pi r square will get cancelled. So k effective is coming out for me k1 plus 3 times of your k2 divided by your 4. So this will be the answer for this. So which option is matching with this one? K1 plus 3 times of K2 divided by 4. Second option. Got it, everyone? Read the question once again and try to do it better. A cylinder of radius r is surrounded by a cylindrical shell of inner radius r and outer radius 2r. The thermal conductivity of the material of the inner cylinder is K1 and that of outer cylinder is K2. Assuming no loss of your heat, the effective thermal conductivity of the system for heat flowing through the length of the cylinder is how much? Formula is K equivalent is K1 A1 plus K2 A2 divided by A1 plus A2. Series and parallel, I told you the combination. Okay. Next one. Temperature difference of 120 degrees is maintained between the two ends of a uniform rod AB. This one is a uniform rod AB of length of how much for me? 2L. That means this is L, means this will be your L by 2 and this will be your L by 2. So total distance will be another. Another bend PQ. Where is another end? Yeah, this one. This part is right now for me PQ of same cross section as AB and length is your 3L by 2. Okay, 3L by 2 means this is L by 4, this is L by 4, L by 2 plus this one is L. So that will be equal to your L by 2, L by 4 half is your L by 2. That means L plus L by 2. Isn't it? L by 4 plus L by 4 is how much for me? L by 2. L by 2 plus L is 3L by 2. Is connected across your AB. As shown in the figure. In the steady state, the temperature difference between P and Q is how much? Can anyone try it better? Take 2 minutes of your time. First read the question and see what better you can understand from that one. Identify where there is a division of the current or heat flow. So I identify which is a series combination and which is your parallel combination. Anyone? Zaid Afnan, Afia, Bariga, Syed Asha Fatima, Nandini. First, identify series and parallel better. That's very important. See, I'll just draw the diagram for you. If there is a flow of current here right now, the moment it comes here, it gets divided here better. One amount of current will go here and certain amount of current will flow here. So this one is L by 2, this one is your L and this one is also your L by 4. So this distance will become for me how much? L by 2. This distance is also your L by 2. What is the resistance formula beta? R is equals to your L by your K into your A. isn't it? So area of cross section is same, thermal conductivity is also same. So R is directly proportional to the length L. Okay, for resistance across your AP will be equal to how much for me? R by 2. Okay, resistance across your Q and B will also be equal to your R by 2. Now resistance across this PQ, I'm taking this one as R and this one is your S. So resistance across your P and PQ, this one is R, will be equal to directly proportional to the length. So this will be equal to your R by 4. Then resistance across your Q and S, that is also your R by 4. Resistance across your P and Q, that will be equal to R. Resistance across your R and S, that is also equal to your R. Okay, this one, and this one. These three of them are what? In series, and that is in parallel with this one. So I can write your effective resistance across this one will be equal to how much beta? So this will be equal to your 3R by 2. And this one is nothing but equal to your R. These two are what? Series, and this one is in parallel. So I'll write here, you see. I'll write the resistors, we'll get an idea. There is one resistor here, there is one resistor here, there is one resistor here, there is one resistor here. Okay, there is one resistance here right now, and there is one resistance here right now. There is one resistance here right now, like this. This is your P, this one is Q, this one is your R, and this one is your S. Okay, the resistance of this one is right now for me how much? R by 2. This one is how much? R. This one is your R by 4. This one is your R by 4. This one is R. This one is your R by 2. This is some terminal of your A and this one is of your B. Sorry, so first I'm calculating the resistance across your P, Q, R, and S. So these three are in what combination, beta? Resistance across your P, R, S, Q. P, R, S, Q. That will be equal to how much for me? R by 4 plus R by 4. So that will be equal to your 3R by your 2. Then resistance across your P and Q is how much for me? P. These two are in parallel, so this will be equal to your, this I am taking it as of your R1, and this one I am taking it as of your R2. So this one is your R1 into your R2 divided by R1 plus R2. R1 is how much? 3R by 2 into, this one is your R, divided by 3R by 2 plus, this one is your R. So this one is 3 into R square divided by 2 plus 3R by 2 plus R. That will be equal to your 5R by your 2. Isn't it? 5R by your 2. So this R and this R will get cancelled. This 2 and this 2 will get cancelled. So this will become for me 3R divided by 5. That means effective resistance across this one bit. Effective resistance across this one totally, I got this one is equals to how much for me? 3R by your 5. Now I'm drawing this diagram, you see. Here there is one resistor, and here there is one resistor, and here there is one resistor. This is a terminal B, this is a terminal A, this is your P, and this one is your Q. Between P and Q, we got the answer. What is that one, beta? That answer is your 3R by your 5. This one is how much for me? R by 2. This one is how much for me? R by 2. So resistance across your A and B will be equal to, all of them are in series. So R by 2 plus of your 3R by 5 plus of your R by 2. That is your R plus of your 3R divided by 5. See how much I'm getting, beta? 8R divided by 5. 5, 6, 7, 8. 8R divided by 5. So total effective resistance is how much for me? 8R divided by 5. Then heat current, if I am taking, H is equals to your temperature difference across your AB divided by resistance across your AB. Temperature difference across your A and B will be equal to 120 minus 0 beta. Because this temperature is given in the problem 120 and this is at your 0 degrees centigrade as per the given problem. See in the problem part. Okay, the temperature difference of 120 degrees is maintained between the two ends of the uniform rod of length 2L and the bent rod of your PQ of the same cross section AB and length 3L by 2 part. Temperature difference means delta T only directly. So this total temperature difference I'm taking 120 divided by 8R divided by 5. That means this is your 120 into your 5 divided by 8 into R. Okay. Yeah. This is the temperature difference across your A and B beta. Now what is asking? Net temperature difference between P and Q. Temperature difference between P and Q. That means that will be temperature of P minus temperature of your Q. Okay. So the temperature difference will be equal to how much beta? This formula I am taking I into resistance between P and Q. Resistance between P and Q is how much for me? This one. Resistance between this PQ is this total is how much for me? 3R by 4 into resistance across your P, Q, R and S. Total current is your I into this one is your 3R divided by 5. So that is equals to, this is your I is nothing but heat current only. Na? This is nothing but of your H. This is your H on there, right? This one is also your H. So H value is your 120 into your 5 divided by 8R into your 3R divided by 5. This R will get cancelled. Now simplify this one. Okay, this 5 and this 5 will get cancelled. So how much I'm getting, you see? 120 into 3 divided by your 8. How much?
45.
120 into 3 divided by your 8. How much, beta? Got it? See, what I did is first, I calculated the effective resistance. Then I calculated the total current flowing in this one. Total current means total heat. H is equal to temperature difference across your A to B divided by resistance across your A to B. That I got as 120 into 5 divided by 8R. Now what we need is your temperature difference between P and Q. That means temperature difference between P and Q will be equal to your heat produced. That is nothing but this one is your H. This one is your H. And this one is also your H. I'll write it neatly so it will be very clear for you. So this will be your total heat in this one, which has been flowing. So that must be equal to your H into total resistance across PQRS will be equal to 3R by 5. So simplify it, we'll be getting the answer for this one. Got it?
Yes, sir.
And this one is 120 into your 3 divided by your 8. Anyone?
360 by 8, sir.
Am I audible to everyone?
Yes, sir.
How much are you getting, beta?
45, sir.
45.
360 by 8.
Yeah, 45 degrees centigrade. So 45 degrees centigrade. Good question. I hope you got it. Next one. Parallel rays of the light of intensity I is equals to 912 watt per meter square are incident on a spherical black body kept in a surrounding of temperature 300 Kelvin. Take the Stephen's constant as 5.7 into 10 to the power of minus 8 Weber per meter square Kelvin to the power of minus 4 and assume that the energy exchanged with the surrounding is only through the radiation. The final steady state temperature of the black body is close to how much for me? So black body radiation only, we need to write it out better. See how much I can write it out. It's very close to his asking right now for me. This one is not 300. This one is 330 Kelvin better. This one is 660. This one is 990. This one is 150. 110. 1150. Sure. Anyone? Parallel beam of light of intensity. Intensity is given for me. I is equals to your 912 watt per meter square is incident on a spherical body. This is your spherical body. So we need to take only the projected area on which this ray of light is being incidented. Okay. We'll be trying to take only the projected area. Projected area means this will be something like this. This projected area. Okay, of radius R. So that the energy radiations from this one is right now coming out like this. from all the directions. Okay, now read the question. Parallel beams of light. These are parallel beams of light of intensity so and so. So how much is that one? 912 watt per meter square is incident on a spherical black body in surrounding of a temperature. Temperature surrounding T naught will be equal to your 300 Kelvin. Let me check with the question first. Yeah, 300 Kelvin. Taking the Stephen's constant at 5.7 into 10 to the power of minus 8 Weber per meter square Kelvin to the power of minus 4, and assuming that the energy exchange with the surrounding is only through the radiation. The final steady state temperature of the black body is close to how much? This is your black body value. So whatever energy is incident per second, that will be the energy radiated per second. I can say that energy incident per second. Energy incident per second must be equal to your energy radiated by black body per second. Okay, so energy incident per second must be equal to energy radiated by the black body per second. So energy formula, you know, energy I can write as intensity is equals to your I into your R. So I can write here from this one, energy incident will be equal to your I wala. So it is your I into your pi into your R square. Because power is equals to your energy divided by your time, or work divided by time. So power is equals to, we know the intensity for this one. Intensity is equals to your power by your area. So power is only the energy. So it is intensity is equals to, this one is nothing but spherical body. So pi into your R square, projected area. Okay, so it is nothing but pi into R square is equals to your sigma into a temperature of the body minus temperature of the surrounding into your 4 pi into your R square. Projected area into the total surface area of the body. So pi R square and this pi R square will get cancelled. So intensity I is equals to your sigma into your, this is T to the power of 4 minus T naught to the power of 4 into your 4. Okay, so T to the power of 4 minus of your T naught to the power of 4 is equals to, this one is given as of your 4. Intensity is given how much for me, beta? That is nothing but sigma value is also given for me. Let me check with the data. Black body surrounding temperature is 300 Kelvin. Okay, this taken Stephen's constant is 5.7 into 10 to the power of minus 8. Okay. This one is T, if I'm bringing this one out, so this one is your I divided by your 4 into your sigma. Intensity is given how much for me, see? 912. Intensity is given as of your 912 divided by 4 into sigma value is 5.7. 5.7 into 10 to the power of minus 8. So that will be equal to 912 divided by 4 into 57 into 10 to the power of minus 9. That means 912 into 10 to the power of 9 divided by 4 into 57. See how much I'm getting this number. So this one is T to the power of 4 minus this one is 300 to the power of your 4. That means T to the power of 4 will be equal to 912 into 10 to the power of 9 divided by 4 into 57. This one is right now for me, this one if it is coming here, this will become for me plus this one is nothing but 3 into 3 into 3 into 3 into 10 to the power of 4. So this 10 to the power of 2 to the power of your 4. Okay. How much are getting visible? T to the power of 4 will be equal to 912 into 10 to the power of 9 divided by 4 into your 57 plus 3 3s are 9 into 3 3s are 9. 9 9s are 81 into 10 to the power of your 8. So in this one I can take 10 to the power of 8 common. So this will be your 912 into your 10 divided by 4 into your 57 plus 9 9s are 81. So that will be equal to 10 to the power of your 8 into this value. You see how much you are getting, better. See how much I'm getting that one, better. This one. This is 10 to the power of 8 into 40 plus 81. So this is 10 to the power of 8 into 120. This is t to the power of 4. Okay. So t to the power of 4 is equals to 121 into 10 to the power of your 8. To the power of 4. This is 10 to the power of 2 to the power of 4. Isn't it? So this will go out. It is 121 into 121 into 121. See approximately how much I'm getting that one. Better. I told you one method yesterday. A square plus b square into your a square minus b square. You do it in that one, you'll get the answer for that one. This will go t to the power of your 2. This is 10 to the power of 2 to the power of 4. Isn't it? So this one, how much I can write here? 33. Okay. See how much I'm getting this one. Below. T to the power of 4 is equals to 121 into 10 to the power of your 8. Anyone? Check the answer and tell me better. If you're not getting the calculation, you please let me know. I'll try to tell you the method. Yesterday I already told you. Still, if you're not able to do the calculation, you please let me know. I'll try to help you out with the calculation. This rod is again this very big question. This is a graph question. This one. Yeah. This one you try better. 3 very large plates of same area are being kept parallel to close each other. They are considered as an ideal black bodies and have the high thermal conductivities. The first and third plates are maintained at temperatures of 2T and 3T respectively. The temperature of the middle, that is second plate under the steady state condition, will be equal to how much? Plates are being kept like this. So whatever the heat is being flowing, it will be same from this one. It is also same from this one. Large plates, each are considered ideal black surfaces and have the high thermal conductivity. The first and third. The first one is having temperature 2T and the third one is having a temperature of 3T. The temperature of the middle plate will be equal to how much? This temperature theta is equal to how much? Can anyone try it? Can anyone try it? See, Q is nothing but rate of flow. Whatever is flowing in the first rod, Q1, that must be equal to your Q2 in the second rod. This one is, say, for example, third one, the middle one. Okay, so Q1 must be equal to your Q2. So sigma into your A into first one is right now 3T to the power of your 4 minus of your sigma into your A T naught to the power of 4. Like say this temperature, I'm taking it as of your T naught. Okay, must be equal to your. Then across this one, if I'm taking right now, that is sigma into A into your T naught to the power of 4 minus sigma A into your 2 T naught to the power of your 4. Simplify this one, you'll get the answer for this one. So it is your sigma, this is your sigma A T to the power of 4 into 3 to the power of 4 minus sigma A into your T naught to the power of 4 is equals to sigma into your A into your T naught to the power of 4 minus sigma A into T to the power of 4 into 2 to the power of 4. All the T naught terms on one side and the remaining terms on the other side. So I can write this one as sigma A T to the power of 4, not having the space to do it out. (97 by 2 to the power of 1 by 4). Correct. This will be the answer. Not having the space in the second page. Yeah. You can do the calculation. I hope you can do it right now. All the T terms you can take on the one side and this one you take on this side and try to simplify. That's it. Okay. Third option will be the answer for this. The next one. Variation of the radiant energy emitted by the sun filament of a tungsten lamp and a welding arc as a function of its wavelength is shown in the figure. Which of the following option is the correct? Sun variation of the radiant energy emitted by the sun filament of a tungsten lamp and a welding arc as a function of its wavelength part of relation. Wings displacement law beta. So for this one, I can use the wings displacement law formula, that is lambda into T is equals to your constant. So if from the graph, if I'm seeing it, let me see the graph, see T1, T2 and T3. So obviously T3 is greater than of your T2, T2 is greater than of your T1. So temperature of the sun will be the maximum beta, T3, isn't it? So temperature of the sun will be the maximum, isn't it? So C option must, although the graphs are not clear for us, so but still I can write from the given condition T3 is greater than of your T1. So wavelength of this one, that means if it is having a temperature of your sun and this one is filament and the wavelength, which of the following option is the correct? T3 must be representing me the tungsten. Tungsten should be representing me T2 and welding arc must be equal to T1. Third option. Obviously, even all this one, I can write only this option correct because temperature of this one should only be the larger. T3 will be the greater compared to the always air condition because the wavelength will be decreasing. So wavelength will be your decreasing. It is inversely proportional. So lambda is inversely proportional to your temperature. That means lambda of your 3 will be lesser than lambda of 2 will be lesser than lambda of 1. Next one. In which of the following process convection does not take place primarily? This you should tell better. Sea breeze and land breeze are because of convection. Boiling water is also convection. Warming of the glass of the bulb due to the filament. This is due to the conduction.
Conduction.
Yeah, heat air around the furnace is due to your heat air around the furnace is due to radiation, isn't it? Will not take place primarily, he is asking. So that means the glass bulb is due to the filament of the radiation. Heating air around the furnace also, it is because of your convection. This is also be a plausible. Is it because there is a transfer of the molecules? But warming of the glass of the bulb due to the filament is due to the conduction. Like the glass bulbs in our houses also, if it is made up of a glass, they become heated due to the conduction. Transfer of the heat from one point to the another point. Next one. This we can try it out once. Yeah, this graph you see better. Very important graph. Can anyone try it better? The graph shown in the diagram represents the variation of the temperature of the bodies X and Y having the same surface area with the time t due to the emission of radiation. Find the correct relation between the emissivity and absorptivity power of the two bodies. That means I can write here right now in terms of your rate of cooling. That is minus of your d theta divided by dt is directly proportional to your emissivity. If it is not a black body, it is directly proportional to emissivity. That means minus of your d theta divided by your dt of your x will be greater than of your d theta divided by dt minus of d theta by dt of your y. There is more rate of cooling is for your x compared to your y beta. That means I can say that energy of your x is greater than of your energy of your y. So emissivity means good observers or good emitters beta. So AX will be greater than of your AY. So what will be the answer beta? EX is greater than AY and AX will be greater than of your AY. Third option. Good observers or good emitters. Or good emitters. Okay. Next one. Anyone this one beta? An ideal black body at room temperature is thrown into the furnace. It is observed that initially it is the darkest body and later times the brightest. It is the darkest body at all times. It cannot be distinguished at all times. Initially it is the darkest body and at later times it cannot be distinguished. Can anyone tell me this one beta? Anyone? Option D. How beta? Nandini? An ideal black body, you know, it is a good observers and good emitters. See, on a black body, if I'm taking, if the energy is being incident completely, so when it is absorbing all the radiations, it will be the darkest initially. And it is also a good emitter. Now, after some times, it will be your emitting also. It will be the latter times, it might be the brightest part. So A must be the answer for this. Initially, it is the darkest, and at later time, it will become for me the brightest. I hope this question you can do it out very easily. I did already in the class for you. This graph initially, this graph also based upon your wings displacement relation. Can anyone tell me what the answer for this one, better? The plot of intensity versus the wavelength for the three black bodies at the temperature T1, T2, and T3 respectively are shown in figure. The temperatures are such that is equal to how much? Wavelength is inversely proportional to your T beta. So from the graph, I can take that wavelength of your first temperature will be lesser than the wavelength of your third one. That will be the wavelength of your second one. So I can say that T1 will be greater than T3 and T3 will be greater than of your T2. T1 will be greater than of your T3 like this. Because in this graph, this is a T1. This is your T3. This one is your T2. So wavelength of your first one is lesser than of your wavelength of your third one. The next one is lesser than of your T2. Okay, so T1 will be greater than T3 will be greater than T2. Clear? Sure. The remaining questions you can try it out better once. Can anyone tell me this question better? Direct question. A spherical black body with radius of 12 centimeter, radius 450 watt, power at 500 Kelvin. I'll write the data. A spherical black body with radius r is equals to a 12 centimeter radius. That means power is given for you 450 watt power at 500 Kelvin. That means temperature is given as 500 Kelvin. If the radius were halved, if the radius was been halved, that means r is equals to 12 by 2. That is equals to 6 centimeter. And the temperature is doubled. That means that T2 is equals to your 1000 Kelvin. The power radiated will be equal to how much? P2 is equal to how much? This is P1, this is R1, this is your T1. So power radiated is directly proportional to your surface area and directly proportional to your T to the power of 4. Okay, so radius is half, so surface area will become for me how much better? 1 by 4 times. So temperature is doubled, therefore T to the power of 4 will become 16 times. So net power will become for me how much better? This will become for me 450 initial power into this will become for me 1 by 4 into your 16. So just simplify this one, this will come out for me 1800 watt. I'm doing nothing, that's it. P1 by your P2 is equals to A1 by your A2 into your T1 by your T2 to the power of your 4. P1 is already given for me 450 divided by your P2, that is equals to area means radius only now, so it is nothing but of your R1 only. I'm writing 4 pi into your R square. That is nothing but of your R1 square. This one is nothing but of your R2 is nothing but of your R1 by 2 whole square. Okay, into T1. T1 is nothing but equal to your 500 divided by this one is nothing but of your 1000 to the power of your 4. This 2 and this 2 will get cancelled. So this will become for me 450 divided by P2 is equals to R1 square will get cancelled. 2 square is nothing but 4 into this one is 5 by 10 to the power of your 4. Okay, so P2 will be equal to your how much? So 5 ones are 5 twos are 1 by 2 to the power of 4. 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. So that will be equal to your 4 divided by your 16, isn't it? P2 I'm writing here right now. So this one is your divided by 450. So P2 will be equal to how much better? 16 into your 450 divided by 4. So that will give me 1800 watts. That's it. I've written directly orally so that it will be easy. Otherwise, you can do it out with the general formula also. Okay, sure. The remaining problems you try to do it out better. And from tomorrow onwards, we'll try to start with the next topic of this. And I'm sending you the assignments of this one. You please try to do the assignments practice on your app basically. Okay? Sure. Take care, beta. Bye.